Hello friends, how are you? I hope you are rocking. Today we'll be learning about induction motors in thermal power plant. First, we will learn about basic working of induction motors. The most common type of AC motor being used throughout the work day is the induction motor. Applications of three-phase induction motors of size varying from half a kilowatt to thousands of kilowatts are numerous. They are found everywhere from a small workshop to a large manufacturing industry. The advantages of three-phase induction motor are listed below. Simple design, rugged construction, reliable operation, low initial cost, easy operation, and simple maintenance. Simple control gear for starting, speed control, high efficiency. Three-phase induction motors are constructed into two major types: squirrel cage induction motors and slip ring induction motors. In thermal power plant, squirrel cage induction motors are used, so we will discuss only those. First, we will see the major parts of induction motor. Stator construction. The induction motor stator resembles the stator of a revolving field three-phase alternator. The stator or the stator part consists of three-phase winding held in place in slots of a laminated steel core, which is enclosed and supported by a cast iron or steel frame on the frame of motor. When the stator is energized from a three-phase voltage, it produces a rotating magnetic field in the stator core. Rotor construction. There are no windings in the rotor of the squirrel cage motor. Instead, it is a cylindrical core constructed of steel laminations with conductor bars mounted parallel to the shaft and embedded near the surface of rotor core. These conductor bars are short-circuited by an end rings at both ends of the rotor core. Actually, the entire construction, bars and end rings, resembles a squirrel cage from which the name is derived. The stator is connected electrically to the power supply, hence it is called primary. Fan is used to pull bearings, stator and rotor windings. Flux from stator links rotor to induction effect, hence rotor is called secondary. The rotor bars are not insulated from the rotor core because they are made of metals having less resistance than the core. The induced current will flow mainly in them. Also, the rotor bars are usually not quite parallel to the rotor shaft but are mounted in a slightly skewed position. This feature tends to produce a more uniform rotor field and torque. Also, it helps to reduce some of the internal magnetic noise when the motor is running. End bells. The function of two end bells is to support the rotor shaft. They are fitted with bearings and attached to the stator frame with the help of studs or bolts. Principle of operation. The operation of a three-phase induction motor is based upon the application of Faraday law and the Lorentz force in a conductor. Alternating flux is produced around the stator winding due to AC supply. This alternating flux revolves with synchronous speed. The revolving flux is called as rotating magnetic field or RMF. The relative speed in stator RMF in rotor conductors causes an induced EMF in the rotor conductors according to Faraday's law of electromagnetic induction. The rotor conductors are short-circuited and hence rotor current is produced due to induced EMF. That is why such motors are called induction motors. Now, the induced current in the rotor will also produce alternating flux around it. This rotor flux lags behind the stator flux. The direction of induced rotor current according to Lorentz law is such that it will tend to oppose the cause of its production, as the cause of production of rotor current is the relative velocity between rotating stator flux and the rotor. The rotor will try to catch up with the stator RMF. Thus, the rotor rotates in the same direction as that of stator flux to minimize the relative velocity. However, the rotor never succeeds in catching up the synchronous speed, which is the rotational speed of the rotating magnetic field. This is the basic working principle of three-phase induction motor. In power plant, there are mainly two voltages that are used. One is HV motors and others are LV motors. Major HV moters are BFP, CEP, CT, FD, EFN motors, etc. And major LV motors are ESP Rapper, Soot Blowers, LDO pump motors, etc. Now let us see where these motors are generally used. hope you enjoyed the video.